Hey guys, Mr. Marone here, bringing you your final flipped video for Chapter 4. So we've talked about 4 methods for proving triangles congruent, 4 shortcuts. We've used side, 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 angle, side, angle, and angle, angle, side. There's actually a 5th one, but it's more of a special case. And that's called the hypotenuse leg method. And this only works when we have right triangles. It isn't for all right triangles, but if you have a right triangle, you can check to use this method. It's the only time that it can be used, so it's worth taking a look at. And this basically says that if I have a right triangle, if the hypotenuse, the longest side, the one across from the right angle, is congruent in each of my triangles, and one of the 2 legs, one of the 2 things that make up the right angle, are also congruent, I have triangle congruence. So in my picture here, in this example, if my hypotenuse, BC, is congruent to EF, and if one of the sets of legs, AB, is congruent to DE, then we can say that the 2 triangles are congruent. That triangle ABC is congruent to triangle DEF. So it's only for hypotenuse leg, only for right triangles can we use this. So as we've seen in class already, you're going to have these proofs. We've got 2 column proofs here, and in this first one they've given us a bunch of information, and we're going to work through it very quickly here. So in this first one they gave us that these 2 are right triangles, so that was given to us, and they told us that ML, this line here, and MN were congruent. So that was also given. So if you look closely, they made the statement that MP is congruent to MP. That's a shared side, so as we've seen over and over again, we can use the reflexive property there. And then finally, once we have right triangles, we have our hypotenuses being congruent, and we have one set of legs being congruent. These are congruent by HL. I'm going to let you guys try example 2 on your own. I'm going to pause the video, let you try it. Seriously pause it and make sure you're trying this before you start up. The more you do proofs, the better you get, so be sure to keep working at these. Go ahead and try it, and then when you come back, the proof will be done. Alright, welcome back in. So as you can see here, they gave us a set of congruent sides, and they also told us that we had 2 sets of perpendicular lines. So that was all given to us. Whenever you're given information like perpendicular lines or like a bisector or anything like that, you then have to define what that is. So in this case, by giving us perpendicular lines, that tells us that angles A and C are right angles. So we can say that the definition of perpendicular lines is that we end up with right angles. We then have that shared side, that reflexive side, DB, and then we are able to say that these 2 triangles, triangle DAB, triangle DAB, I know Billy's going to be very excited about that, is congruent to triangle BCD by a hypotenuse leg. Now, we've talked about this already at the top of our kind of triangle congruence sections here, this idea of CPCTC. Corresponding parts of congruent triangles are also congruent. So now we've got these 5 techniques to show that triangles are congruent. Once we've got that, we can use CPCTC to highlight specific parts of our triangles also being congruent. Notice that you can only use it after you've proven the triangles are congruent. You can't jump ahead. You can't say that 2 things are the same unless we've proven the entire figures are the same. So looking at these 2 pictures, they want to know, can we assume that C and G are congruent? Since we've got 2 sets of congruent sides with an included angle, we can say yes, because these triangles are congruent by side, angle, side. Since they're congruent by side, angle, side, we can definitely say that C and G are congruent using that CPCTC rule. Okay, and can we prove the triangles congruent? Yes, and that was through side, angle, side. So I got a little ahead of myself writing that in. So once we know that that's true, we can say that triangle ABC is congruent to triangle EFG, and then we get to writing the congruence statement. That's where we talk about all the congruent parts in each triangle. So for instance, like AB is congruent to EF, and BC is congruent to FG, and AC is congruent to EG. Those are all three of our sides. And then our angles that correspond as well. We have A and E, we have B and F, and then we have C and G. And right there, number 6 comes right here. We know that C and G are congruent because they are corresponding parts in their own triangle, and the triangles themselves are congruent. So once again, it's the same text as above. Cannot reiterate this enough. You can only use CPCTC at the very end. So if you're doing a proof, CPCTC can only be the final reason. There's no other place for us to put CPCTC. I don't know if I can say it any more forcefully or any different than you can only use it at the very end. All right, these two proofs we will be doing in class to start tomorrow. So save these. If you'd like to give them a try now, that would be awesome. Otherwise, you can save them until we come into class tomorrow. Have a great night, guys. See you soon.